Okay, so we just got through watching the Brain Pop Junior video on gravity. Now we're going to read this story, so listen carefully. I may be asking some questions as we go through the book. This is called Gravity is a Mystery by Franklin M. Branley, illustrated by Edward Miller. Sir Isaac Newton is the first person credited with discovering the force of gravity and how it kept objects in space, the Earth and the Moon, in their orbits. His theory is called the law of universal gravitational attraction. The attractive force of gravity between two particles is proportional to the product of their masses and inversely proportional to the square of the distance between them. We don't need to know all that. That is just... But we are going to read about Sir Isaac Newton. He is the first person who came up with how gravity pulls us. Okay? There is a force called gravity. He's the first one. What's his name? Sir Isaac Newton. We're going to read about him today. Suppose you could dig a hole to the center of the earth. Suppose you dug right past the center. If you dug long enough and deep enough, you would come out in the Indian Ocean. Okay? So here's the Indian Ocean.
What about the Southern Ocean? What do you dig from there, please?
If you jumped into the hole, you would fall down. Down and down you would go. You would fall faster and faster toward the center of the earth. When you reached the center, you would be going so fast you could not stop. You would go right past the center. Then, on the other side, you would move up and away from the center of the earth. You would fall up for a while. You would go slower and slower. Then you would stop. You would almost get to the Indian Ocean, but not quite. Now you would fall back toward the center of the earth. You would go faster and faster, right past the center. You would not quite reach your starting point. So what is he doing?
He's
Going back up. Back and forth you would go. Each time you would go a shorter distance past the center. Back and forth, back and forth. Gravity would make you fall toward the center of the earth. When you moved past the center, gravity would pull you back again. After a long, long time, you would stop moving. You would stay at the center of the earth. Gravity pulls everything toward the center of the earth. When you run downhill, gravity pulls you. Slow down. When you throw a ball up, gravity pulls it down. Fetch. When you sit, gravity holds you down. When you lie down, gravity holds you to the bed. But what is gravity? Lie down. We know gravity is everywhere, even though we can't see it. We know it pulls on every rock, every grain of sand. It pulls on everything. But no one knows exactly what gravity is. That's why we say gravity is a mystery. Look at all those question marks. And the arrows, isn't that kind of neat? Why is it going down?
Because gravity is pulling it down.
Pulls you down. So gravity is a force. Is it a push or a pull?
A pull.
A what? A pull. Okay. The gravity of the earth pulls everything toward the center of the earth. You know this when you try to lift a heavy stone. Gravity pulls it down. The more the stone weighs, the more gravity pulls on it. To lift the stone, you must pull up harder than gravity pulls down. You already know how much gravity pulls on you. Do you weigh 60 pounds?
No.
That means the pull of the Earth's gravity on you is 60 pounds. How much you weigh tells how much gravity pulls on you. How much a stone weighs tells how much gravity pulls on the stone. Okay, so when you get your weight, that's actually the gravitational pull pulling you down. The Earth has gravity and so does the moon. If you were on the moon's gravity would pull you toward the center of the moon. The moon has less gravity than the Earth. This means the moon's gravity does not pull as hard as the Earth's gravity. Do you weigh 60 pounds?
No.
If you were on the moon, you would weigh only 10 pounds. The pull of the moon's gravity on you would only be 10 pounds.
What if you weighed 1,000 pounds?
Okay, so the pull on the moon is not as strong. Okay, that's why you weigh less. You feel more weightless and like you could float. Okay, there's the moon. So the pulling force is not as strong on the moon. The Earth and the moon have gravity, and so does each of the 9 planets. Jupiter and Neptune have more gravity than the Earth has. On these planets, you would weigh more than you weigh on the Earth. On Neptune, you would weigh only a little more. On Jupiter, you would weigh a lot more. Do you weigh 60 pounds? On Jupiter, you would weigh about 142 pounds. So that actually means on Jupiter, is the gravitational force stronger or weaker?
Stronger.
Stronger. That's why you weigh more there. Gravity on Mercury, Venus, Mars, Saturn, Uranus, and Pluto is less than it is on the Earth. On these planets, you would weigh less than you weigh on the Earth. On Venus, Saturn, and Uranus, you would weigh only a little less. But on Mercury, Mars, and Pluto, you would weigh a lot less. Do you weigh 60 pounds? On Mercury and Mars, you would weigh only about 23 pounds. Even less on Pluto. Is Pluto a planet?
Yes.
Not anymore.
Why?
Not anymore. Now it's considered a dwarf planet. Okay, so we actually don't have 9 planets. We have 8. Okay, so do all the planets have gravity?
Yes.
Yes. Some have more than others, right? That's why we weigh different things when we go, if we were to go on these other planets. Suppose you weigh 60 pounds. This is about how much you would weigh on the moon, on each of the planets, and on the sun. 5 pounds on Pluto, 10 pounds on the moon, 23 on Mercury, 23 on Mars, 53 on Uranus, and 55 on Venus. 55, 60, 67, 142, and on the sun, 1,680 pounds.
I wouldn't touch the sun.
Well, you wouldn't be able to. Okay, you would burn up. You would burn up even when you got not even close to it. You would burn up. Okay, so that tells us what? If you weigh that much on the sun, what does that tell us about its gravitational pull?
It's really hot.
It's really strong, right? So do you think that plays a big part in why all the planets orbit around the sun? Yes. Because it's pulling all those planets to keep it around, orbiting it constantly, okay? If you were on Mars, gravity would pull you toward the center of Mars. You could stand up and sit down just as you can on the Earth. It would be easier to move around, though, because you would weigh less. You could run in big giant steps because gravity on Mars is much less than it is on the Earth. That would be kind of fun if you weighed less. You could make big giant steps and kind of float around.
Yes, I want to jump on Mars.
Jump around, do backflips.
Wait, what if you run? My uncle can do that.
You would weigh a lot more on Jupiter than you do on the Earth. It would be harder to move around on that planet. Your legs would get tired from carrying you. Try running with a 90-pound pack on your back. That's what it would be like all the time on Jupiter.
What if you're lifting weights on Jupiter?
Gravity is everywhere, on the Earth, on the Moon, and on Jupiter, Mars, and all the other planets. The Sun has gravity too, and so does every other star. Did y'all know the Sun was a star?
Yes.
Yep. The gravity of the Earth holds things on the Earth. It holds down rugs and tables, and you and me. We know where gravity is. It is where?
Everywhere.
Everywhere. And we know what gravity does, but no one knows exactly what gravity is. What does gravity do?
Gravity makes us stay from floating in the air.
Wait, it's magnetic
Keeps us
force.
pulled down. Yes, it's a magnetic force that pulls us down. Good. Okay. This is just an activity that we could do on gravity, which we may get to next week, and then some facts about gravity. This is pretty interesting. Planets have a spherical shape because of gravity. So even the shape of the planets, which a sphere is just a ball shape, is because of gravity. Gravity is the weakest of the 4 fundamental forces of the universe. The gravity of the Sun is so strong that it holds all 9 planets in the solar system in their orbits. We just talked about that, didn't we? Don't forget that the Earth is 93 million miles away from the Sun. That is a strong gravitational pull. Okay? We're that far away and we're still being pulled in by the Sun. Pretty amazing. Okay? And the last one, your mass stays the same no matter where you are. If you are on the Moon, your weight is 1/6 your weight on the Earth. But your mass is exactly the same. Okay? So mass is how much space you take up. Weight is actually how much you're being pulled down or how much you weigh on the scale. Okay? Pretty interesting. Okay, so now what we're going to do, we're going to learn more about the person who came up with this, what do we call it, gravity, who came up with this theory that gravity pulls us down. What was his name again? Go back to the first page. What was his name? Sir Isaac Newton. So we're going to read about him and how he came up with a gravitational law and answer some questions, okay?